You're watching the Intel Network Builders vSummit series. I'm Guy Daniels, Director of Content at TelecomTV. Now, a key facet of an agile 5G network is that it is built on a cloud-native architecture that provides benefits such as flexibility and service creation, which are realized due to the distributed nature of the software and the associated microservices and service mesh. Well, joining me now to explain more about the integration of microservices with the 5G network core are Rajesh Gadiyar, who is CTO of the Network Platforms Group at Intel, Marco Palladino, CTO and co-founder of Kong, and Dejan Leskarowski, VP and Head of PLM, EPC and 5G Core at Mavenir. Hello everyone, thanks so much for taking part in our discussion on the 5G network core. Rajesh, let me start by asking you, what do you see as the advantages and challenges of moving to a cloud-native architecture for 5G?
Yeah, first, thank you for having me on this panel, Guy. It's great to partner with Marco and Dejan for this important discussion on 5G and the benefits of cloud native architecture. So, our industry has really made incredible progress with network virtualization. The resultant disaggregation of hardware and software in network applications is real, and our industry is seeing significant benefits like reduced total cost of ownership and an open architecture that is fueling innovations like never before, including deployment of new services at the edge on these open platforms and options to better monetize the network infrastructure. Now, this has delivered significant benefits for the industry already. The disaggregation of hardware and software does two things. First, it allows our ecosystem and customers a much faster innovation cycle, and they can innovate in software and deliver new features and capabilities. Second, it delivers the benefits of a much larger ecosystem. So it is not just the traditional OEMs, but also new players such as Mavenir and Kong that are delivering new innovations in the 5G and edge infrastructure. So now that we have laid this foundation with hardware software disaggregation, the next phase is all about disaggregating applications with a cloud native approach. Network application vendors are looking to embrace the cloud native paradigm using microservices packaged as containers. And edge computing is all about this disaggregation and distributed computing. So it is about bringing, in many ways, it's about bringing a cloud closer to the application and process data closer to the user. So cloud native approach is, in my mind, fundamental to realizing the full benefits of 5G and edge. It delivers two key benefits. First, it makes 5G applications flexible and composable with microservices, so you can embrace distributed computing and meet the key performance indicators or performance KPIs of applications with efficiency. And second, massive at-scale automation using Kubernetes as the cloud operating system. And I'm super excited and proud of our collaboration with Mavenir and Kong that are driving some key innovations in this cloud native transition.
Thank you, Rajesh. Well, let me now turn to Dejan. Dejan, what makes the distributed software methodology such a benefit to the network operators?
So the distributed software provides flexibility to the operators. So as they're building their next generation 5G networks, it really gives them a flexibility of how to build these networks. So it's no longer about building one large centralized data center that addresses a kind of one specific consumer model. Now they actually can build data centers that have distributed architectures. So they can have local data centers, regional data centers. Of course, centralized data centers will still apply, but then also be able to use the same network, in this case, the 5G core, to address multiple use cases. So the network can address consumer, which they already have, but also can actually scale up or scale down to address massive IoT. If they need anything in terms of supporting edge type of applications, or even, for example, network slicing for particular enterprise use cases, then they can scale down particular network functions and deploy those network functions much, much closer to the end user. So just to kind of expand a little bit more, the disaggregation really happened with 5G in two main areas. One is how you actually disaggregate the software within a network function, meaning I'm creating microservice-based architecture. I'm decoupling the application from the underlying infrastructure. What that enables you to do is really scale down when you really, really have to. So you can actually deploy a particular network function like a user plane on a few P cores, or really scale up, but you're not actually scaling up the entire network function. In other words, you're not adding multiple NFs, you're not adding multiple UPFs, but you're actually adding microservices within a network function. So that's one area of flexibility: scale out, scale in, depending on the use case. By distributing the actual functionality, so if you look at or compare what 4G versus 5G and what the 3GPP specs have done, they have defined over 20 different network functions. And there is a reason for that. The reason for that is that now you can actually take particular network functions like your AUPF, like your session management, SMF, AMF, deploy them in a local data center or deploy them at the edge. And you can have things like subscriber management or policy management still be centralized. So really overall gives that flexibility to customers to address a variety of use cases, but yet still build and deploy the same converged packet core.
Thank you, Dejan. And Rajesh, the benefits sound very, very clear.
Yeah, I completely agree with Dayan, right? So the disaggregation of software and distributed computing is the only way to achieve the level of automation, resiliency and fault tolerance, and composability of network applications, and also scaling the services on demand for the applications of tomorrow. So from the operator perspective, all of the above have a bearing on total cost of ownership and also the ability to monetize their network infrastructure beyond the network pipes.
Thank you, Rajesh. Marco, turn to you now. We hear a lot about using a service mesh to facilitate the communication between 5G services, but can you explain to us what is the service mesh and why is it so important to the cloud-native 5G network?
Today, we have assessed that we're going to be having decoupled, decentralized applications running across the board. And whenever we decouple and decentralize our applications in services or microservices, we are adding the network at the backbone of those applications. Now, that introduces a big challenge. The network, as we all know, it is not safe, it's not reliable, it's not observable. The network really is these black box that we have to manage in order to create successful applications in a decentralized way. Without anything else in our infrastructure layer that we provide to the application teams, well, the application teams are going to be left building all of these network management capabilities by themselves, but we don't want them because that's not their job and because that makes them lose efficiency. They should be focusing on building the services, the products, and the features, not building the infrastructure. So service mesh is a new pattern. It's relatively new. It was introduced in 2017 or so, and it allows us to essentially provide a reliable, safe, and secure and observable network to all of our applications and to every service that our teams are creating from an infrastructural standpoint in such a way that our application teams are not going to be the one building these capabilities anymore, but they're going to be the consumers of these capabilities.
Thanks, Marco. And Rajesh, do you share Marco's view there on service mesh?
Yeah, absolutely. I think Marco had a great description of service mesh. Just to add, from my perspective, I like to think of a service mesh as the new communication fabric for microservices. It is the common networking, security, load balancing, and observability features that are so critical as we sort of like scale out with microservices. So it's important that we focus on this communication fabric and implement the service mesh in the most optimal way possible, keeping in mind some of the key latency, quality of service requirements for 5G and edge services.
Thank you, Rajesh. And Dejan?
Yeah, just to compliment on Rajesh and Marco, in fact, Marco touched on it. The whole idea of building kind of the next 5G core network is for the vendors that are building the 5G network to focus on applications. So there's no need to reinvent or recreate things that are already established as part of the platform as a service or container as a service components. So service mesh plays a big role. The importance is that if you're trying to actually implement service mesh-like functionality as part of the application, you're defeating the whole idea of reusing or leveraging existing components that the community provides. So that's why it's important, not just service mesh, there are other, of course, components from monitoring and logging, but service mesh brings a big value, and it's important that application vendors focus on the application and integrate a service mesh to actually take the advantage of what service mesh provides.
Well, let me follow up on what you just said there, Dan, and let me ask you, what is the key to ensuring that the software and services work seamlessly with the infrastructure and service mesh?
Yes, so I think the initial answer is very simple, but I'll elaborate. The answer is you have to build software that is cloud native, and you have to build software that is agnostic to infrastructure. Now, that's very easily said. In fact, has been used by almost every vendor. But how you build your software and how you achieve or how do you get to cloud native is the key part. You have to build software, especially when it comes to this kind of telco software into cloud from ground up. Microservices in mind, stateless microservices, kind of to pick up on the previous answer, use and leverage existing platform components. We talked about service mesh. There is a slew of services that are widely adopted, not just by the telco community, but also by other industries. So when it comes to monitoring, when it comes to troubleshooting, scaling, orchestration, automation, the application that the vendors are building, like Mavenir, have to make sure that they actually adapt and use those type of tools. There has to be some commonality of how we actually achieve that. The other thing is, again, it's important of how the software was developed. Many of the vendors, have been there for a long time and have evolved from, maybe originally from a proprietary hardware to software only, to running in VMs, to running in containers. Each one of those evolution steps has its own unique challenges and requirements. So if a application developer simply serves the software or migrates the software from one infrastructure to the other, then they're going to kind of face this uphill battle of being infrastructure agnostic and seamlessly integrate with the infrastructure. So moving specifically to the 5G core, the development has to be done from ground up. There has to be some prior investment. It's always hard to invest in and develop something, but the results at the end are having agnostic software, having something truly cloud native, not just saying that it's cloud native, but really be agnostic and be able to integrate with all the tools we talked about: CI/CD pipelines, service mesh, observability, automation, Kubernetes scaling. All of those things have to be taken in consideration because otherwise you will always have a challenge with seamlessly integrating. The last part I just want to say, it's not just about the vendors. It has to be obviously a close partnering relationship with our ecosystem, with our partners. So working with the partners to make sure that telco specific requirements, and telco has sometimes unique requirements, to make sure that those are part of the infrastructure. So we are not forced to actually develop in the application. And then working with our operators. We talked about distributed architecture. What happens now is the packet core is no longer going to be a single vendor solution. They're going to be multiple vendors. So working with our operators and making sure that the requirements are well understood, and then we actually can deploy multiple vendors on the same common infrastructure.
Thank you, Dan. And Marco, as you said earlier, service mesh is relatively new. So are there any challenges that need to be overcome when deploying service mesh with software and services?
Well, the first challenge is education. I think service mesh has been presented by the industry as this extra thing that we have to do, when in reality, it is something that we already have to do, and the teams are doing it for not providing this functionality via the infrastructure layer. Education of what service mesh is and the main use cases of a service mesh are critical to fully roll out a service mesh in production and being successful with it. So first and foremost, understanding what are the use cases that we're trying to implement as a step number one, being able to determine, are we doing this because of the zero trust, the encryption, the routing, the observability, the cross-cloud or cross-zone communication? Is it because we want to remove load balancers, traditional legacy centralized load balancers that have no place in a decentralized architecture? With a service mesh, we can apply client-side load balancing to improve the performance of our systems as well as reduce cost for managing those centralized load balancers. So what's the use case that we want to start with? And service mesh is just a way, it's a pattern that allows us to implement these use cases across the board, across both containers and virtual machines and single cloud, multi-cloud, and multi-cluster, most importantly. And understanding what is the number one challenge that we want to tackle and where we go from there. That is the biggest success factor for deploying a service mesh in production. When service mesh is not being deployed in a successful way, it is because those goals are not clear. Service mesh is being deployed, and then after the fact, we are trying to wonder what are the benefits of it. And so that's not the right approach. And then education that needs to happen not only within the application teams and the architecture teams, but also in the business. The service mesh is something that is going to be accelerating our business agility and the velocity of shipping new features, because we're removing away a big chunk of the work, which is managing the network, away from the application teams, like we said earlier. That makes the application teams much faster. It makes them consumers of this connectivity, and they can create more services and more applications without having to worry about all these complementary features that we have to have in place in order to make these services functioning in the first place. And that education, it is not just technical, therefore, it is business education into understanding how the business can benefit from that. Now, service mesh is only one of the 3-4 connectivity challenges that we have to address. Of course, service mesh is great when we try to connect our services within the context of an application. But today, service mesh doesn't give us the right governance in place to determine which subset of these services we're going to be exposing to a third-party user. It can be a customer, can be a partner, can be a developer community. And so service mesh is very good for certain use cases, but not for others. The invasive deployment model of service mesh does require a sidecar proxy, typically, to be deployed across all of our services. But if the service is outside of our network, outside of the org, then we cannot mandate that. So service mesh has to work in combination with a ingress or an API gateway or an API management solution that allows us to determine what subset of services we want to expose to either outside of the org or to another team, what governance rules in place we want to have to determine how that access is being performed, and the gateway and the mesh will communicate together to enable that flow of information in a seamless way.
Thank you, Marco. Rajesh, how is the industry making it easier for operators to adopt and deploy a cloud-native 5G core into their networks?
Guys, so we really live in exciting times. So 5G deployments are in full swing around the world, and 5G is fueling an innovation cycle like never before, particularly at the edge. With new deployment models such as private wireless, and embracing cloud native architecture is so fundamental to realizing the full benefits of 5G and edge computing. Now, cloud native is the key to delivering efficient, scalable, and automated end-to-end services. And our vision at Intel is to collaborate with our partners and deliver leadership solutions for this era of distributed computing with 5G and edge. So I would like to emphasize 3 key things. First, we are delivering a market-leading product and technology roadmap from Intel. The vision we are driving is a standard Xeon server is the best-in-class network platform and delivers the best total cost of ownership for our customers. Second, it is to drive the software innovations that are required for cloud-native transformation, including the service mesh optimizations that we have been talking about on this panel. So to accelerate and support the transition to cloud-native, we are offering a robust set of software platforms and toolkits that are built on open APIs and frameworks for workload acceleration and convergence at the edge. So a good example of this is Intel Smart Edge software for multi-access edge computing, consisting of both a commercial software and a royalty-free software toolkit. We also have our FlexRAN reference software that accelerates 5G vRAN deployments. Other SDKs, such as the Open Visual Cloud for video analytics, graphics, and immersive media, Open Vino Toolkit to optimize, tune, and run AI inferencing, and Intel Edge Insights and Edge Control software that allows for easy deployment of software-defined AI and control systems for industrial IoT applications. And third, we continue to foster an open and vibrant ecosystem for new and innovative network and edge solutions. Our idea is to ensure hardened and deployment-ready solutions that are commercially supported. All this is really making it easy for operators, service providers, that is, and other ecosystem partners to embrace cloud-native and drive faster innovation cycles.
Well, I've got a final question for all of you. And Diane, I think I'll start with you, if I may, and that is, what else should architects and engineers be considering when choosing the software and hardware components for their cloud-native 5G core network?
A couple things I may touched on a little bit, but maybe I should expand the way they actually build their network function. So there's a couple of things that definitely need to consider. One is try to isolate processes to a microservice level. Now, again, there's no one answer that fits all, but when it comes to creating a particular network function, depending what the network function does, there are kind of best practices in terms of how you isolate processes. How do you actually create those processes so they are at I would say, a P-core level or even a fractional P-core level. The reason why that's important is, one, you actually can optimize the resources that each microservice uses. If one microservice fails, does not impact other services. The way it scales, for example, if let's say we have a particular network function, I'll use one of the more common functions in the 5G core, the AMF. The AMF can have 5, 10, 15 different microservices. Not all services do the same heavy lifting. So when it comes to scaling, instead of kind of the old traditional way of, if I need a new AMF or MME equivalent on the 4G side, typically operator had to add another network function. With a microservice architecture, out of the 10 microservices, maybe there's 3 microservices that do the heavy lifting. So those microservices are now scaled by adding simply single P cores each time. I know that maybe it's a very common one-on-one kind of how you build a cloud-native architecture, but within telco, we have to be, I don't want to say more disciplined, but those are the main things that telco has to embrace. Vendors like Mavenir are embracing to make sure that when I build a 5G AMF, a 5G SMF, I use this microservice architecture. I assure that they can run in a very, very small footprint. So I can actually deploy a full network on a single server for an enterprise use case, or I can scale it to actually support tier 1 customers. The other thing that, again, should be a common requirement, but at times may be overlooked, make sure your microservices are stateless in nature. When things are stateful, and this was kind of the evolution from proprietary hardware to VMs. If things are stateful in nature, a lot of things are more complex. Resiliency, redundancy becomes more complex. You may have now requirements to do one-on-one redundancy, which obviously wastes resources. Scale out and scale in becomes more complex. By moving to a stateless architecture, all of those things become much, much simpler. So you're really, again, I've repeated myself maybe a couple of times, but it's really kind of getting to that true cloud native architecture while you're building your network function. The last thing I want to say is, again, focus on the application. If you're a 5G core vendor, you focus on the application. There are well-established tools when it comes to observability. There is well-established tools as part of the cloud native community when it comes to scaling, orchestration, automation, service mesh. All of those tools are available to us. So there's no need to actually kind of reinvent the wheel when it comes to that type of platform as a service tools that are already available. So it makes our development quicker. We focus on the application itself, and then we simply integrate with the platform components that are already available and provided by the community.
Thank you, Dan. And Marco, additional advice from you as what we should be considering when choosing components for cloud-native 5G core networks?
Yeah, I have a couple of points. The first one is about automation. We are just at the beginning of our journey in creating services and microservices and applications that are going to be supporting all of these different use cases, including 5G. And this is just the beginning. They're going to get 20x, 30x, 100x bigger in the years to come. We have to have the right processes in place and the right automation in place to be able to identify problems and then self-heal our microservices without human intervention. Things like service mesh can help us with that. But without an automation in place to detect anomalies in our traffic, to be able to self-heal the connections and the requests when they're failing, we're not going to be able to build a reliable infrastructure that is going to be powering all of these modern use cases. So automation is number one. Number two is the adoption of open source to generate some, if not most of these functions, open source software. The industry has created an open and portable way to package our software, and we call that containers. We have a portable and neutral way to deploy our software, Kubernetes. And we must have a portable and neutral way to create a reliable network connections within our services with all the open source service meshes that are available today. Open source allows us to be portable, to be neutral, allows us to be able to migrate across different platforms and different vendors, and also gives us leverage in the future if we were to move away or select a new vendor for our infrastructure. Open source today is a self-service, and quite frankly, it is the main driver to the bottom-up transformations we've been seeing in the market in the last few years, with the creation of Docker in 2013 and Kubernetes in 2014 and CNCF, this self-service ecosystem of products and software that we can easily adopt. So open source, it's a great leverage when it comes to the control we have in our systems, which again is going to be the backbone not only of our applications but of the business itself.
Thank you, Marco. And Rajesh, final thoughts from you.
Yeah, I think both Dejan and Marco made some really good points. So from my perspective, 5G and edge computing are converging network and application services. So it's really important then that you choose a hardware platform that is optimized to run both. So for example, Intel FlexRAN reference architecture gives you the best platform for virtualizing the RAN. And Intel Xeon platform is also optimized for 5G core. The 5G user plane functions deliver over 300 gigabits per second of throughput per CPU node, the best in the industry. Now, the technical community also needs to think about embracing the cloud native software paradigm, service assurance, redundancy, observability. Many of the things that we talked about in this panel are key considerations. Automation, I think Dejan talked about this, with the CI/CD approach is an important consideration as well. So I would ask that the technical community fully embrace the cloud native approaches. There are challenges, but together we are solving these challenges. So I look forward to working with our partners, Mavenir, Kong, and others to make cloud native adoption in 5G and edge applications the cornerstone of next generation network and edge applications.
Thank you, Rajesh. That's a great point and a great moment to draw our discussion to a close. Thank you all very much indeed for joining us and participating today. And don't forget to watch the other programs in this Intel Network Builders vSummit series. As well as the Network Core, the series also takes a detailed look at vRAN, edge and security. For now though, thank you for watching and goodbye.